Hi everyone, in this lesson we will build a logistic regression. Using Python and NumPy, and we will apply it to the Titanic dataset. So we will use a Titanic dataset. Our goal is to predict whether a passenger survived or not. So this is a binary classification problem. The output only two values, 0 and its means didn't survive, and 1 and its means survived. Before writing the code, let us first understand the mathematical behind logistic regression. The model starts with a linear equation. So z equal w1 x1 plus w2 x2 plus until wn and xn plus p. So we have weights and feature, and maybe we have more than one feature, and we have the bias. This is the bias, and x feature for feature, and w for weights. So we multiply each feature by a weight, and after that we add them together and we add the bias term. Okay, we will simplify the idea. So we will only explain one feature. So z will equal wx plus p. Suppose we have x equal 2 and w equal 1.5. and p equal -1. Now we can substitute these values. So z equal 0.5 multiply with 2 plus -1. And it will give us 3 minus 1 equal 2. So the linear output is 2. Now the next step, we will pass this value into sigmoid function. So the next step, we have a sigmoid function. Y hat equal 1 over 1 plus e to power minus z. And z the output for linear. So y hat equal 1 divided by 1 plus e to power minus 2, and it gives us, or we can calculate first e to minus 2 to power 2. It's near to 0.135. So y hat equal 1 over 1 plus 0.135, and it will give us approximate 0.88. So the predicted probability is about 0.88. Now we convert probability into a class. If the probability greater than or equal to 0.5, it give us a class 1. And if it's less than 0.5, it gives us a class 0. This, it's called a threshold value, and we can change it. So this is a condition for which the value for a probability belong to which a class. So since we have 0.88 is greater than 0.5, so the predicted class is 1. Now let us look at the loss function in logistic regression. We use a binary cross entropy. So the formula is L equal minus y log for y hat plus 1 minus y multiply with log 1 minus y hat. So we can suppose the true label is 1, so y equal 1. This is suppose or suppose. For it will give us a true label. So we have a class. We have a class, it's equal a 1. And the predicted probability y hat is equal 0.88. So we have two values, one for predicted probability and another for true label. Now we can substitute L equal minus 1 log 0.88 plus 1 minus 1 log 1 minus 0.88. So L equal minus log 0.88 plus 0. So L equal minus log 0.88. So the output for L, or the value for L, equal 0.128. So this is a small loss, so the prediction is good because we got a small loss, so the prediction is good. If the prediction were bad, for example, if the true label is still 1, but the prediction probability is only 0.10, so then we can say L for minus log 0.10, it gives us 2.303. This is much larger, so the loss tells us how wrong the model is. Now, how does the model improve? It improves using a gradient descent. We took it already in the linear regression. We update the value parameter using W equal W minus alpha differentiate for L, W, and P equal for bias, update bias, P equal P minus alpha for P. So in each step, the model change the weight and bias to reduce the loss. We may also add a regularization to reduce overfitting. So we add regularization to reduce overfitting. Overfitting. For L1, regularization loss equal binary cross entropy plus lambda multiply with summation for absolute value for W. And for L2 regularization loss will equal binary cross entropy plus lambda summation W square. Now that we understand the mathematical and we are ready for the practical workflow. First, we will go to Kaggle and download the Titanic dataset. So we need only two files, train and test CSV. This for test and another for train. We can download it. And as we know, Kaggle for we can find more than data sets. And we can, for example, search for Iris data set and we can find it and download it. Okay, so we will start from a drive and we will create a new folder called Logistic regression. And we will open it and we will upload the file and we will change only the names for the file, rename, test and train .csv. After that, we will create a new file, Google Collaborator file. This is a new notebook. We will change the name, for example, Logistic. Regression. Okay. We'll close the sidebar. So inside Collab, the first thing we do is mount to Google Drive so Collab can access the dataset file we write. So from google.colab import drive and drive dot mount content drive, and we can run it. We will show a pop-up to agree the access. We can click connect to Google Drive, and we can give a permission. Continue. After that, we will import the main libraries, and we have import NumPy as MB, import pandas as PT, and import the matplotlib library as BLT. Okay, only we need this library, as we know, the NumPy for calculation, and pandas is for working with tabular data, and matplot library for plotting. Then we need to load the data set, so we need a new parameter. For example, we can add a new text, and we can put two hash to make it more small than import library, and we can load the data set. So we will create a new variable terrain data frame is equal pt.read csv, and we will copy and paste from the link for the training file, so we can open the drive, and after that we will click also to open my drive, and we can search for logistic regression folder, and we will open it. And from this dot, we will open it and copy path, choose copy path. And we will paste the link here. And for test, as we see, test for data frame equal pd.read.csv, and the link for test CSV file also. So after we display the first, so we can also print the shape for train data frame and for test also. And as we see, we have 891 row for training, and for testing we have 418. So we have 891 rows and we have a 12 column and we have also in the data frame 418 rows and we have 11 columns. After that we can print also first 5 rows if we want to print it and train data frame dot hit. And we can see here the data passenger ID and survive and be close and name and sex and age and all of these columns. After that we can also print the columns. So print columns and we will print the train data frame dot column dot tool list because we want to return the list of all columns name in the training data frame. So we can run it and we can see the output. So we have this column, passenger ID, survived, P class, name, and all of these column, and the target will be survived. So we need to determine which the feature and which the target from the columns. So we need a new variable feature columns, for example, and we will put p class and set and age and set sp and parse and fair and impact and the target columns. Only we have one column and it will be survived. So we need after that xdf data frame will equal train will equal train data frame and we will take only the feature columns. Features column and we will make a copy from it. And we will put also y equal train df and we will take the target column and we will convert it to numpy and we will put the type is integer. So we want to convert it to numpy. And we want to ensure all the value are integers. Type equal integers. So and explicit will equal this data frame and we will take also feature columns and we will make a copy. So it will take the same feature columns from the test data and store them in X-test data frame. So we will only change the name to data frame. and we can run it. We need make a preparation for the data, so we need to check if is there any missing data in our dataset or not. So we will print only missing values before pre-processing. And we will print x data frame dot is null, and we will make a sum for all the value. So we will check whether each value is missing, and we will sum or count how many missing values exist in each column. As we see here, we have age 177 value missing, and we have an embarked also 2 value missing. So after that, we will store almost the number of missing value per column in the variable missing count. So we will create missing count variable, and counts equal x data frame is null dot sum. Also, we can figure or plot all the missing value. We can see it more better. Plot dot figure and figure size equal 8 and 4. So the width will be 8 and the height will be 4. And the plot bar for missing counts dot index and missing counts dot value. So this will draw a bar chart where the x-axis is column names and the y-axis is the number of missing value. And we can put x label and y label as we see. And we can put also the title for the chart. And we can plot dot x ticket rotation. We can put it 45. So this rotate the x-axis label by 45 degrees, so they are easier to read. Also, we can, if we want to add a grid, and we will go to dot show to show it. As we see here is the all missing value count before pre-processing for each column. So after that, we will start for processing and solve all missing data. So we can calculate the median for the age. It's data frame age dot median, and we will not fill it now, and we will calculate also the median for first column. and also invert only. We will take or, or we will compute the most frequent value in the impact column and takes the first mode. This will make it. We can run it. And now we want to save the value. Age. We want to fill the missing value, for example, in age with the median age. So x data frame equal x data frame. For age dot fill NA, fill all nullable value with age median and with fair median. And we will also invert with invert mode. Yes. So we can print it again to see if there any missing data or not. So we didn't have any missing data here, as we see. So we will print again the head, for example. We want to see the first row, 5th row. Okay, as we see here, the 6, it's a string and the invert also a string. So we need to map all these value to be integer. So we need x data frame for 6 and we will map the value for male, we will put 0 and female, we will put 1. So this converts the text value in 6 into number in the train set. And for X test also data frame, the same. Exactly. So we will solve also X data frame for invert. We will put, for example, 0, C0 and S1 or Q1 and S2. And we need it also for invert for this data, I mean. And we can copy it and paste it. After that, we can print also the head, the first 5 row to ensure. Yeah, all of these changed to number here, as we see. So we filling missing values and encoding the categories. After that, we need to create a train test split function. So we have x all equal x df dot number to number and the type float. So this converts the cleaned training feature into a NumPy array of floats. And we need exist again, for example. So we need it the same also, but for test data. After that, we need to define a new function, train test split, and we will pass this parameter x, y, and test size equal 0.2. 0.2, it's a 20% from the original data, so we have 80% from the data for training and 20% for testing. And we need also random state, or we can call that seed. After that, we will create a random number generator with a fixed seed, so the split will be the split so is reproducible. The same seed, the same shuffle for all students. And also we will get the number of rows in x dot shape 0. And we will create an array of indices from 0 to n minus 1. So we have idx or idx equal mb dot range for n. After that, we will shuffle the indices randomly. After that, we will compute how many samples should go into the validation set. And we can only to change this variable, for example, validation n. We need to determine which part will takes for validation data and which for the training data. Validation, it's the same for testing. Here we mean it. So we will take the first part of the shuffle indices as validation indices and the remains indices as training indices. So x train will equal x train for indices and y train or y, yeah, y train will equal y for train indices. And x is valid. Yeah, exactly. Validation, we will take the validation also. After that, we will return the four split datasets. We will return x train and y train and x valid and y valid. So we have these variables here. It will equal this split and for x all and y, and we can change this size if we want. but we didn't want to change it. And also speed equal 42. If we didn't want to change it, we can didn't pass it. So we will print the shape for x train and x valid and y train and y valid. X train shape. And we can run the cell as we see the output for x train shape and y train shape and x valid and y valid. As we see, the row should be equal for training and the row should be equal for testing. And also the y is always only we have one column. But for feature we have 7 features to training or to validation. So we have 4 features. So the next step, we will store the position of the numeric columns that we want to standardize. So we want only these in numeric indices equal 0 and 2 and 3 and 4 and 5. Why we didn't take the first here? We Why we didn't take the first? Because as we see the data set here, we have passenger ID, we need it for training. Survived, we didn't want to normalize it because the class or the target, but we need the another all of these. We need it to make a normalization. So only we put the indices 0 and 2 and 3 and 4 and 5, or we can put the name for all columns we want it for feature column. We can work with any of these way. So trend mean, we will calculate or compute the mean of each selected numeric column using the training set only. And after that, we will compute the standard deviation also of each selected numeric column using the training set. And we will add STT. And we will add a condition if is there any standard deviation is 0, we replace it with 1 to avoid division by 0. So the normalization, the numeric columns in the training set, we need this equation. We made it before, but we made it in another way, only this another way to do it, and we know it. I didn't need to explanation for it, because I explained it in the lectures. So we will also make it for validation. And we will make it also for X test again. Again. Okay. So we need to first to print first three rows of X train after normalization or standardization. So we have all these value as we see for normalization. Now we want the main functions for logistic regression. So we need to define a sigmoid, and I think all of you know why we need a sigmoid. It will equal mb dot bit z minus 500 and 500. So this limits large values of z to avoid of overflow in the exponential function. And we will return 1.0 divided by 1.0 plus mb dot exponential or minus z. This is the equation. I explain it in the this video. And we will define a new function. It's called predict probability. And we'll take it and W and B. To compute a predicted probability. After that, we will compute the linear score. Z equal X multiply with W plus B. So X at W plus B. And this the same if we want to write it in another way. Z and B dot and dot X and W plus B. This is the same way to write it. And after that, we will convert the linear score into a probability. So we need to return the sigmoid Z. After that, we need also to define a new function to convert a probabilities into a classes. So predict we have, and it will take X and W and B and a threshold. And I explain what's the threshold before 0.5. And we will get the predicted probability, so we need Y probability equal predict probability X and W and V, and we will return 1 when a probability is at least the threshold, otherwise we will return 0. We will define also a function, accuracy score, and we will pass y true and y predict, and we will compare true labels and predicted labels, then return the fraction of correct prediction. After that, we need to apply the binary cross entropy function. Binary cross entropy function, and it will take the parameter y true and y probability and w and regression type and regression lambda. After that, we will create a very small number to avoid taking a log of 0. So we have epsilon equal 1 in minus 12. And after that, we will keep a probability away from exactly 0 and 1 only. We will keep the value only between 0 and 1 and be dot clip y probability and epsilon to 1 minus epsilon. After that, we will start to computing the average binary cross entropy. So data this will equal minus mb dot mean y true multiply with mb dot log y probability plus 1 minus true multiply with mb log 1 minus y probability. We need another bracket. So this is a binary cross entropy formula for each sample. After that, we will get the number of samples and will equal length for y true. And we will check whether we are using L2 regularization. We will start with L2. And we will put regression loss will equal regression lambda divided by 2 multiply with n multiply with mb dot sum w to power 2. This will compute the L2 regularization term. So we have LF also regression type for L1. Regression loss will equal regression lambda divided by n multiply with mb dot sum for mb dot epsilon for W, and this will compute the L1 regularization. So else if we didn't pass L1 or L2, we didn't need regularization. So the loss or the regularization loss, we will set it with 0. After that, we will return data plus regression loss. We will also create a new function, define a gradient descent or compute gradient, and we will pass x and y and w and b and regression type and regression lambda also. First, we will get the number of sample and will equal x dot shape 0. We explained how to compute a gradient before, but only we will write it only with another way also. Here we will compute the predicted probability. After that, we will calculate the error. Y probability minus y. It will compute the difference between a prediction and true value. After that, we need to compute the gradient of the loss with respect to the weight. So dw will equal x transpose at error divided by n. And for bias also, MB dot mean for error divided by n. If regression type L2, we will add the L2 gradient term and if regression type is it L1, we will also add the term for L1 dw plus equal regression lambda divided by n multiply with mb dot sign w, and we will return here the dw and the b. We will define now the main function for a train logistic regression with the gradient descent. So we will define a function, train logistic function, and we will pass the input and the target, and learning rate will equal 0.05, and ebooks, how many iteration we need to put, we will put it 3000, and we will pass also the regression type, which regularization, and we will pass also regression lambda, and also feed, 2, and the final verbose every. Not important, but I need I added it. I have to add it. Really. 200 because only I want to print only uh, like zero and the iteration. I didn't want to print all of these 3000 iteration. Only I need to print, for example, 0 and 200 and 400 until 3000. Okay. After that, we will create a random generator. R and G will equal mb dot random default RNG with seed, and we will start the number of sample n and the number of feature m from Xshape, and we need to initialize the weights with small random values. So RNG dot normal, and we will get 0 and 0.01 for size equals m, and initialize the bias equal 0.0, and we need to create an empty list to store the lost at each epoch. So lost history, and we will create the main loop to start the training from epoch 1 to the final epoch. So for epoch in range 1 to epochs plus 1. We will compute the predicted probability for the current weight and the bias. Y probability will equal predict proba or probability, and we will pass X and W and B. After that, we will start calculation the loss. So loss will equal binary cross entropy, and it will take Y through will take Y and Y probability will take Y probability, and W it will take W. And for regression type will take regression type, and regression lambda it will take also regression lambda. So we need to pass all of these, and after that we will save the current loss value. So loss history dot append loss, and after that we will start calculating the gradients. Compute gradient, and we will pass X with X and Y with Y. We didn't need because the same really. Regression type also the same here. And the final regression lambda. After that, we will update the weights and update the bias. So W will equal W minus LR multiply with DW, and bias will equal bias minus LR multiply with dB. So only we will check whether to print progress at the first epoch or every fixed number of epochs. So we need F epoch equal 1 or epoch mod verbs every equal 0. We will print epoch, but we need to calculate the prediction of the current epoch. So we need y predict epoch will equal predict XW and V, and accuracy for also accuracy score for Y and Y predict. But for book, yeah. And after that, we will print we didn't need really this one book and 4 digit only. And plus, and we will take float, and also we will print the accuracy for here. And we will return W and V and loss history. We will run it. So we will choose L2 as regularization for training, and we will set the regularization string for regression lambda is equal 0.01. And after that, we will training and store the final weight, bias, and loss history. So we need a regression type will equal L2 and regression lambda 0.01, and we will start training W and V and loss history will equal the train logistic regression gradient descent, and we will pass for X because it's not the same the parameter. It's equal X train, and Y will equal Y train, and learning rate will equal 0.05, and epochs will equal 3000, and regression type will be the regression type, and regression lambda be the regression lambda, and seed 42 and purpose every 200 only with the sprint progress every 200 epochs. So after that we can run it. As we see, the accuracy at the final 79%. So we need to compute the predicted probability on the training set. So we need train probability will equal predicted probability for X train and W and B and train prediction also, but we need also here for validation probability will equal predicted probability exactly, and for also valid prediction will equal predict and X valid and W and B. So first we will compute the predicted probability on the training set, this one, and another one for or on the validation set. We compute the prediction probability, and after that we convert the training probability into classes a prediction for validation and for a training. After that, we need to compute the training loss. So we need train loss will equal binary cross entropy, and we will pass y train and train probability and W and regression type will equal regression type, and regression lambda will equal regression lambda. And also the same for validation loss will equal lambda. And we need also training accuracy. We need to calculate the accuracy or to compute the accuracy for training and validation. So we need to print only the final loss on the training set and on the validation set. And we will print the final accuracy for training and validation. So we will print train loss, train loss and validation loss for validation loss, and the train accuracy the same. Exactly as we see here, the output for the training loss and the validation loss and the training accuracy and validation accuracy. After that, we can plot if we want the figures. and 5, for example, 12 or 4 or 7 and 4. We can change the number really, and we will plot the lost history, and we can put X label will be ebook, and the Y label will be lost, and the title will be loss over time. And we can put red if we want to, and the plot show. As we see here, the loss should be decreasing. It starts from high, and after that will become near to zero. We can also make a quick comparison between regularization L1 and L2, and if we didn't use any regularization also. So we can print quick comparison we want, and for temp regularization type and none and L1 and L2, and lambda will equal 0, 0. If it's none, else will equal 0.01. After that, we will calculate W and for bias underscore will equal train logistic regression gradient, and we will pass X will equal X train, and Y we will pass it Y train, and linear regression learning rate 0.5, and epochs will equal 3000, and regression time will equal also temp regression type, and regression lambda will equal temp lambda, and seed equal to 2, and there was every 200, or we can put any number we wanted. After that, we will compute the prediction on the training set and on the validation set, and after that also we will compute the accuracy for training and for validation, and we will print one comparison line for the current regularization type. So temp train prediction will equal predict x train and temp w and temp P, and temp valid also predict, we will predict, and temp here training accuracy will equal accuracy score, and then W, and then for bias. Now, yeah, we will edit only these because only we will compare between Y valid and valid probability. Exactly. And we will print here and regression type. Train accuracy will equal 10 train accuracy. And then we will take 4 digits after the comma and validation. And valid accuracy. Floating. uh, And we can run it to see the output. Without any regularization, the training accuracy 0.79 and validation accuracy 78, and the same for L1 and L2, the same for all of these. So here we can finish from the logistic regression as we see, and if there any question you can send to me to ask. Thank you very much.